Alright, last part. Find a trapezoidal approximation of the definite angle from -3 to 15 of f of t dt using 6 subintervals with a length of 3. Now, a lot of times when they ask you to do trapezoidal approximation, you usually don't have this many intervals. 6 intervals is usually 3 or 4. But, so use the trapezoidal approximation. Probably don't remember that formula off the top of your head, but it looks harder than it is. Alright, so the area using the trapezoidal sum is going to be 1/2 times delta x times f of x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2 plus dot 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 f of x sub n minus 1, I'm sorry, 2 times that, plus f of x sub n. So again, this looks more complicated than it is. Let me kind of explain what this means. This f of x sub 0, the x sub 0 part, that's like our a, like our starting x value on the interval, and the x sub n is going to be our b. What happens is we're breaking this whole graph, in this case, into 6 parts. So we're going to have from -3 to 0, that's actually going to create a triangle, not a trapezoid. From 0 to 3, again, makes a triangle. 3 to 6, this one does make a trapezoid. 6 to 9 makes another trapezoid. 9 to 12 makes a triangle. 12 to 15 makes a triangle. So we're looking at those 6 shapes, adding those up to approximate this area. Well, the f of x sub 0, that means like our a value here at -3. This y value is like the height of the triangle. And there should be another height here, but it ends up being 0. That's f of x sub 1. But then this height at 0 is also a height for this other one, this other shape next to it. That's why there's 2 of these. And then if you look at this triangle, this side is shared between the triangle and the trapezoid. That's where there's 2 of those, and so on. But the endpoints, these heights only get used once, so that's why there's only 1 here and 1 there. So that's kind of the big idea to remember. So for this problem, we're going to end up with 1/2 times 3 times this height right here, the y value at x equals -3 is -1, plus 2 times our next y value, which is at 0, so 2 times 0, plus 2 times our next y value is 1, plus 2 times our next y value is 3, plus 2 times the next y value is 1, 2 times the next y value is 0, and then our last y value, there's only 1 of those, so plus -1. So we end up with -1 plus 0 plus 2 plus 6 plus 2 minus 1. We end up getting 8 in there for an area of 12. Now, there's an easier way to figure this out, but I'm just not sure if they'll take points off or not because they ask you to use the trapezoidal approximation. I don't know if they'll take a point off if you don't use it, because it could very easily be done if we look at this area and this area, this one's negative, this is positive, those kind of cancel each other out. Same over here. So really all we have to do is find the area of these 2 trapezoids and add them up. That would give us the same answer. I'm just worried because they ask you to use the trapezoidal approximation that they might take points off if you don't use it. Yeah, yeah.